Today, we are going to discuss the completely randomized experimental design. Completely randomized experimental design is a type of experimental design used in statistics and research. In this design, participants are randomly assigned to different treatment groups. Each participant has an equal chance of being assigned to any of the treatment groups, and the assignment is completely independent of any other factor. The purpose of using a completely randomized experimental design is to reduce the potential for bias and confounding variables, as well as to increase the statistical power of the study. There are 5 steps in a completely randomized experimental design. To implement the experiment, researchers must first identify the research question and the independent and dependent variables. After identifying the independent variables, step 1 of the experiment is to design the level of contributing factors. That is, the independent variables. In an experiment, the values or levels of a contributing factor are also called treatments. For example, in a medical drug experimental test, having the drug or not is the factor. And we typically have 2 treatments: receiving the drug and receiving a placebo. The design of the experiment is to ensure that any observed differences in the response variables, that is, the effectiveness of using the drug, between the treatment groups are due to the treatment and no other factors. Here, we provide an example of step 1. Suppose that a company intends to evaluate the efficacy of 3 distinct sales tactics, strategies A, B, and C, on the performance of the sales team. In step 1, we can identify that the factor in this scenario is the sales strategies, while the treatment including strategy A, B, and C. The response variables is the sales team's performance. In step 2, we need to specify the experimental unit. Experimental units are the objects or individuals that are subjected to the treatment or interventions in an experiment. This unit can be any type of physical or biological entity that is capable of receiving the treatment and producing a measurable response. In some experiments, the experimental units are human subjects, while in others, they may be animals, plants, or even inanimate objects. For example, in a clinical trials to test the efficacy of a new drug, the experimental unit would be the human subjects who are receiving the treatment or a placebo. In the sales performance experiment, the experimental units are the sales team's members. In this case, the company may randomly select 60 salespeople for the experiment. The selection of experimental units is critical in experimental design, as it can impact the validity and generalizability of the result. Ideally, in step 3, the experimental unit should be chosen in such a way that they represent the larger population of interest and are randomly assigned to the different treatment groups to reduce bias and confounding variables. For example, in an experiment where 15 experimental units are to be assigned to 5 treatments, we can randomly pick 3 experimental units for each treatment. In the sales performance experiment, given that there are 60 experimental units and 3 treatments, we can randomly select 20 salespeople for each sales strategy. In the 4th step, after assigning the experimental unit and conducting the experiment, the value of the response variable is recorded for each experimental unit. This allows us to obtain a sample of response variables values for each treatment. In the sales performance experiment, step 4 involves providing training to each group on their respective sales strategy. This means that Group A will receive training on strategy A, Group B on strategy B, and Group C on strategy C. The next step is to allocate a predetermined period during which each group will implement the assigned sales strategy. For instance, 1 month. At the end of this period, it is important to assess the performance of each group. This can be done by utilizing appropriate metrics, such as the total revenue generated, the number of sales closed, or the average deal size. In order to determine if there are any significant differences in the outcome due to the different treatment, the 5th and the last step of a completely randomized experimental design is to compare the results between the treatment. For example, in the case of the sales performance experiment, in step 5, the results between the groups need to be compared to determine if there are any significant differences in sales performance due to the different sales strategies. This comparison will help in identifying which strategy performs better than the others, and whether there's a statistically significant difference between the treatment groups